A 4K microscope camera can show fine PCB details clearly, yet still fail the inspection workflow if operators cannot capture, retrieve, or act on the evidence they need. The right choice depends less on the connector name than on what each bench must accomplish. Observe, compare, capture, annotate, archive, share, or connect. A rework station may require an immediate live image on a nearby monitor, with simple controls and minimal dependence on a computer. A non-conformance review may require captured images, sample identifiers, annotations, and reliable retrieval. An engineering workstation may also need network access, software compatibility, and defined ownership of configuration and records. These are different evidence paths. They should be defined before a camera is approved, especially when a factory is standardizing equipment across incoming inspection, in-process review, rework, and engineering investigation. Standardization can simplify training and spare planning, but a common camera configuration can create friction when it is forced into a task it does not support efficiently. HDMI is useful for direct, monitor-based work. It gives the operator an immediate live view without requiring a capture application, maintained PC, or file management step for every task. That makes it practical for rework, quick visual confirmation, training, and side-by-side review. HDMI alone, however, does not create a traceable inspection record. When retained evidence is required, the team must define a separate capture process or use a configuration with a controlled storage path. USB is suited to benches where a PC is part of the inspection cell. The computer can support live preview, image capture, annotation, measurement software, folder management, and access to a quality system. The result depends on implementation. Buyers should test the intended operating system, software version, driver or UVC behavior, image format, file naming method, permissions, and the time required to move from observation to a usable record. Gigabit Ethernet becomes relevant when the camera belongs to a connected work cell. It can support a broader local network plan, but the interface is not an automatic approval advantage. Addressing access control, cable routing, software connection, IT ownership, and recovery procedures must be verified. The team must also establish who owns the images, who can retrieve them, and how records are protected from accidental overwriting. Resolution is only one part of inspection quality. A 4K output may make fine features easier to view on a suitable display, but reliable evaluation also depends on the sensor, lens, working distance, lighting, focus, depth of field, display scaling, and operator task. A high-resolution image produced with unsuitable optics or poorly controlled light can still leave a solder bridge, lead condition, surface mark, or component code ambiguous. Testing should use the actual PCB, representative components, normal illumination, the intended lens and mount, and the required working distance. The trial should include real operator actions such as moving a board, adjusting focus, freezing an image, capturing evidence, or comparing a suspect point with an acceptable condition. A practical selection grid can prioritize inspection response, record traceability, operator independence, network fit, and deployment complexity. These factors should be weighted according to the bench. A rework station may prioritize immediate visual response, while failure analysis may prioritize capture, annotation, and retrieval. The Fantru B368MP4K digital microscope camera provides a documented starting point for this evaluation. This published information lists a 1/1 8-inch Sony CMOS sensor, C or CS mount compatibility, HDMI, 2 USB 2.0 ports, gigabit connectivity, storage support, image freezing, recording, and on-screen measurement functions. Those features still require local validation with the selected lens, lighting, software, network, and samples. Approval should cover the complete station configuration: camera, optics, lighting, display or PC path, operator controls, storage location, naming rule, retrieval responsibility, and escalation process. A successful pilot begins with a representative PCB and ends with a second person retrieving the resulting evidence. That complete work cycle reveals delays and ownership gaps that a short product demonstration may not show. The result should be an approved inspection workflow, not simply a purchase order. HDMI, USB, and gigabit Ethernet can each be appropriate when matched to the work the bench must perform.